So on A, we want to simplify this expression. And so it says tangent theta cosecant theta. So we know that tangent theta is equal to sine theta over cosine theta. And we know that cosecant theta is equal to 1 over sine theta. And so those are two identities that we're going to use. So I know that tangent theta cosecant theta is going to be equal to sine theta over cosine theta times 1 over sine theta. And so I can rewrite that as sine theta over cosine theta sine theta. Then I notice that since there's multiplication going on down here, that it's essentially multiplying by sine theta over sine theta. So that's going to be 1 over cosine theta times sine theta over sine theta. And this is 1. So that's equal to 1 over cosine theta. And 1 over cosine theta is secant theta. So this is secant. Okay. And the next one, I'm probably going to use the fact that sine squared theta plus cosine squared theta is equal to 1. So that's one of the Pythagorean identities that I can remember. And so first I'm going to start by multiplying that out and multiplying that out. So if I have cosine theta plus sine, or cosine x plus sine x squared, that means cosine x plus sine x times cosine x plus sine x. And then plus, and then I want to square cosine x minus sine x squared, so it's cosine x minus sine x times cosine x minus sine x. I'm almost out of room there. And then I can multiply that all out. So when I do cosine times each of those, and then sine times each of those, and cosine times each of those, and then negative sine times each of those. Okay, so cosine times cosine is cosine squared. Cosine times sine is cosine sine. Cosine x sine x. And then sine x times cosine x is sine x cosine x. And then sine squared x. And then I'm going to go plus cosine times cosine again is cosine squared. Plus cosine times negative sine, so it's going to be minus cosine x sine x. And then I'll have minus sine x cosine x. And then plus sine squared. Okay, and so then all of that is on one line. So it got a little crazy there. But what I might notice is that I have some like terms here. Cosine x, sine x. So those guys. And so when I add all of that up, that all adds to 0 because cosine x sine x minus cosine x sine x. Then sine x cosine x minus sine x cosine x. So this is all equal to cosine squared plus sine squared plus, and then I have a cosine squared plus sine squared. Okay, and then I know this here is equal to 1, and this here is equal to 1. And so what I'm left is 1 plus 1, which is 2. That simplifies all the way down to 2. Okay, so the next one says I'm given an expression for theta. I need to find expressions for cosine and tangent with theta in the first quadrant. So your answers will be algebraic expressions in terms of x. So if I know that x is equal to 4 sine theta, then I can divide both sides by 4, and I get sine theta is equal to x over 4. So I can draw my triangle in the first quadrant and label my side theta here. And I know sine theta is x over 4. And so I can label this side as x and this side as 4 if I want to. And then I can find the third side. So since this is a right triangle, I know that this side here, I'm just going to call it K or something, or maybe I'll call it, I don't know, I can call it whatever I want. Maybe I'll call it M or something, I don't know, I'll call it B. Okay, so I have B squared plus X squared equals 4 squared. And then I could solve for B. So I get B squared equals 16 minus X squared. So B is equal to the square root of 16 minus X squared. And again, that B is a plus or minus, but since we're in the first quadrant, it's going to be the plus one because the X and Y are both positive in the first quadrant. Okay, so that's that side of that triangle. So I'm going to label it now. Okay. So this is square root of 16 minus X squared. And so now I can write down my trig functions here. So I know that cosine of theta is going to be that x over r, so it's square root of 16 minus x squared over 4. And tangent theta is opposite over adjacent, so it's going to be x over square root of 16 minus x squared. Okay, and that's that. On number 18, it says, gives me a value for tangent theta and tells me what quadrant we're in. So I know that we are in quadrant 3, excuse me. So this is pi, and this is 3 pi over 2. And so we're down here. So here's our angle theta. And I know that the tangent is 5 over 2. So I can label this as -5 and this as -2. I know they're both negative because I'm in the third quadrant, and that is, I'm going in negative direction in the x and a negative direction in the y. Okay, so what is cosine theta? So what I can do is I can solve for the third side of the triangle here. So 5 squared, -5 squared, plus -2 squared is equal to c squared. And so what does that give me? C is equal to square root of 29. Okay. And so cosine theta will be equal to the x over r, so -2 over square root of 29. Sine of theta will be the y over r, so -5 over square root of 29. And secant theta is 1 over cosine, so I'll just take my cosine and flip that, so it's negative square root of 29 over 2. Next it says if cosine of t is a over b, what's the exact value of cosine of -t? Okay, so cosine of t is a over b. So we know that cosine of negative, this is a symmetric argument here. So if I know what cosine of t is, when I think about the symmetry of cosine, hang on. Maybe I'll erase that for now. Let's think about the symmetry of cosine. It's symmetric, has reflective symmetry. So if I know what t is, then if I look at -t, it should be the same y value. So for any value t, the -t has the same cosine value. And so that's the property that we want to use here. And so, because cosine is what we would call an even function. So, what is this? Okay. So, there we go. So cosine of -t is equal to cosine of t. And that's true for all values of t. So the exact value of cosine of -t is that it's equal to cosine of t, which is a over b. Okay. Then for the inverse trig functions. For the equation n equals sine inverse of m, which letter represents the angle? And so I have to think about what sine and sine inverse do. So I know that sine takes inputs of angles and gives an output of ratios of sides of triangles. Or you could think of it as y-coordinate on the unit circle. And so the function sine x goes that way. You input an angle into sine and you output a ratio of side of triangles. But sine inverse goes the opposite way. In other words, if you know the ratio of side of triangles, you can plug it into sine inverse and you get out an angle. So for this one, this is not an angle, but this one is an angle. So the output of sine inverse is an angle. So n is the angle. So you input into sine inverse, the thing you input is a ratio of sides of triangles. And the output there is an angle. So the angle is in there, not in. Find the angle theta in radians in the second quadrant, whose tangent is negative 4.5. Okay, so let's use our calculator to find tangent inverse. So I know that tangent theta is equal to negative 4.5, okay? And it's in the second quadrant. And so I can do tangent inverse. So theta is equal to tangent inverse of negative 4.5. And let's see what we get. I'm just going to do my calculator. Oh, it wants it in radians, so I'll do it in radians. So we'll do tangent inverse of negative 4.5. So I get negative 1.35 there. I'm going to round to 2 decimals, okay? But if I think about where 1.35 radians is, that's going to be down here in the fourth quadrant. So if I do 1 radian is about a radius length of my circle. So 1.35 radians is going to be over here somewhere. Okay, and so so that's not the angle I want, because I want the second quadrant angle. Okay, so it needs to have that as its reference angle. So what I can do is I can go all the way around to 180 and then go back that amount. So if I do 180, or sorry, not 180, if I do pi minus 1.35 radians, I will get the angle 1.789 radians, or 1.79. Okay, so if I do, so pi goes all the way to there, and then I can take off the 1.35 radians, and that gives me that same angle. Okay, next one. Solve the equation for a value of theta in the first quadrant. Okay, so if I want a value of theta in the first quadrant, I want the answer in radians and degrees. Okay, so round radian angles to 3 decimals and round degree angles to 1 decimal. All right, so if I manipulate this, I can add the 5 over and divide by 8, so I get cosine theta is equal to 5 over 8. And I want it to be in the first quadrant. So I can find the theta to be, I can use my inverse cosine of 5/8. And in radians, that's 0.896 radians. And if I write that in degrees, I can just change my mode to degree mode, and I could do cosine inverse of 5/8. That gives me 51.3 degrees. Okay. Number 23 says solve the equation, again, between 0 and 2 pi, so we're going to probably solve this in radians. And it gives me that equation there. And so what I'm going to do is I'm going to move everything that has tangent on it to one side and everything on all the constants to the other side. So if I subtract 5 tangent theta from both sides, tangent t, excuse me. Tangent t plus 4 equals 6 tangent t plus 5. Okay, so I can subtract 5 tangent t from both sides. I get 4 is equal to tangent t plus 5, and I could subtract the 5, and I get tangent t is equal to -1. Okay, so what angles have tangent value -1? So for an angle to have tangent value -1, that means that sine theta and cosine theta are equal up to a sine. So that means that, so that's going to be at the 45 or pi over 4 degrees mark there, and are going to be my reference angles. And then I know that tangent is like the slope of the line, the terminal side. And so, if the slope is negative, that's going to be the second quadrant or the fourth quadrant. And so if I think about the angles, that's going to be, let's see, if I think about splitting this up, this is pi over 4, 2 pi over 4, so 3 pi over 4 is an answer, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So at 3 pi over 4 and 7 pi over 4, I'm going to have tangent value equal to -1. Because the sine is root 2 over 2, negative, and positive root 2 over 2 on cosine. And here the sine is positive root 2 over 2, and the cosine is negative root 2 over 2. And so the answers there are t is equal to 3 pi over 4 and 7 pi over 4. And I'm just solving in this range from 0 to 2 pi. So that's all for now. Okay, for the given triangle, find the exact values of sine theta, cosine theta, and tangent theta. So the first thing we'll need to do is find the missing side. So I'll just call it b. So I know 3 squared plus b squared equals 7 squared. And so that gives me b squared is 40. So b is equal to 2 square roots of 10, or square root of 40, which is 2 square roots of 10. You could write it as square root of 40 if you want, though. And so I'm going to go ahead and label that side there with that value, square root of 40. Okay, and so then sine theta is going to be equal to opposite over hypotenuse, so 3/7. Cosine theta is going to be adjacent over hypotenuse, so square root of 40 over 7. And tangent theta is y over x, or opposite over adjacent, so 3 over square root of 40.